Hello everyone. Now today we are going to discuss one of the problem on Green's theorem. I think is the second one. Verify Green's theorem for integral over c y sin x dx plus cos x dy, where c is a triangle formed by the coordinate points 0, 0, pi by 2, 0 and pi by 2, 1. Okay. Now look at the triangle shape. How we going to get it using of these 3 points. Now first 0, 0. Now 0, 0. Next pi by 2, 0. Pi by 2, 0. Now pi by 2, 1. And let origin 0, pi by 2, 0 is A, pi by 2, 1 is B. Connect these all 3 points, you can get a triangle. Okay. Now I take an anti-clockwise sense here to get the line integration. That's why I put it a mark like this. Okay. Now I'm going to verify the Green's theorem. First write the Green's theorem. Now Green's theorem is integral over c pi dx plus psi dy equal to integral over the region E dou psi by dou x minus dou pi by dou y dx dy. Now first find the value of LHS, next find the value of RHS. We need to show that these two are same. Okay. Now these two values should be same. Now first go for consider of LHS. Now LHS integral over c pi dx plus psi dy over the line integration. Now is like a triangle. Triangle formed by the 3 lines, right? Now over that we need to integrate. Now first along OA, next AB, next BO, right? Along OA plus along AB plus along BO. Okay. Now C can be divided integral over OA pi dx plus psi dy, AB pi dx plus psi dy, now BO pi dx plus psi dy. Now first along OA, now this OA line is lie on x axis. Now where the y value is 0, right? On x axis y value is 0. Now deviation of y also 0, simply dy is 0. Now x varies from 0 to pi by 2. 0 to pi by 2. Now integral over OA y minus sin x dx plus cos x dy. Now x equal to 0 to pi by 2. Now where y value is 0, right? Simply substitute y value 0. Now this value is 0, remaining minus sin x dx dy 0. Okay, this quantity is 0. Now integrate with respect to x, minus common. Integration of sin x is minus cos x, limits are 0 to pi by 2, minus into minus plus cos pi by 2 minus cos 0. Cos pi by 2 is 0, minus cos 0 is 1, 0 minus 1 is minus 1. Now next along AB, for this along AB line equation simply is x equal pi by 2, where y varies from 0 to 1. The line equation x equal pi by 2, where we have the deviation x is 0. Okay. Now y varies from 0 to 1. Now integral over OB y minus sin x dx plus cos x dy. Now where y varies from 0 to 1, y minus x value is pi by 2, sin pi by 2 into dx is 0 plus cos x cos pi by 2 into dy. Now 0 into something is 0 plus cos pi by 2 0 dy. This also 0. 0 plus 0 is 0. The total integration of 0 is 0. Now along BO. For along BO, now is a line passing through the points of 0, 0 and pi by 2, 1. Now we need to find out this line equation passing through these 2 points. Now use the 2 points form of the equation y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. Now simply find this line equation. Now line equation you can have that 2x by pi. Okay. Now where x equal pi by 2 here, pi by 2, pi cancel, 2 cancel, y value is 1. Okay. Now is x equal to 2x by pi. Otherwise use this formula, you can get the line equation. Okay. 2 points form of the equation, right? Now this we need to use it, y1 x1 y1 x2 y2. Now these points substitute here, get the equation y equal to 2x by pi. Okay. Now that relation I am going to use it for BO line. y equal to x by pi, dy is 2 by pi into dx. Okay. Now y varies from, x varies from, we try to get for each term as x, but we look at this y sin x dx plus cos x dy. Now this total term we try to convert as x terms. Now for that I use a y value to x by 5. That's why I write for here x limits. X varies from pi by 2 to 0. If you want to change for totally y term, then you use the y limit. But if you want to change it here to totally x terms, easy to convert it. That's why x limits are going to use it here. Now x varies from pi by 2 to 0. Okay. Now substitute the y value to x by pi minus sin x dx plus cos x into dy. Dy is 2 by pi into dx. Now dx common. Now 2x by pi minus sin x here plus cos x. Now that integrate with respect to x. 2 by pi constant. Now x integration x square by 2 minus sin x integration minus cos x plus 2 by pi constant cos x integration sin x. Limits are pi by 2 to 0. Now apply the upper limit. Now here x value 0, simply 0. Minus into minus plus cos 0 is 1 plus sin 0 is 0 minus lower limit pi by 2 applied. X equal pi by 2 whole square, right? Now it's pi square by 4 by pi. Now minus into minus plus cos pi by 2 plus 2 by pi into sin pi by 2. Now 1 minus, now here 1 pi cancel, remaining pi by 4 plus, now cos pi by 2 0, 2 by pi into sin pi by 2 is 1, right? 2 by pi into 1. Now is 1 minus pi by 4 plus 2 pi. Okay. Now total LHS quantity, now integral over c y minus sin x dx plus cos x dy is integral over OA is minus 1, AB is 0, right? OA is minus 1, AB is 0. Next BO is 1 minus 1 by pi plus 2 by pi. Plus 1 minus 1 cancel, the remaining minus pi by 4 plus 2 by pi. Now this is the LHS quantity. Now we need to go for RHS now. For RHS, integral over double integral over E dou psi by dou x minus dou pi by dou y. Okay. Now first find these derivatives. Now pi y minus sin x, psi is cos x, dou pi by dou y with respect to y derivative is 1 minus sin derivative is 0. Okay. Sin x derivative with respect to y, right, is simply 0, nothing but is 1. Now dou psi by dou x cos x integration is minus sin x. Now dou psi by dou x minus dou pi by dou x dx dy. Now dou psi by dou x is minus sin x, here minus dou pi by dou y is 1. So we can common minus here. Now to this integration we need to pick up the limits. Okay. Now for that again I draw the region here. Same O point and A point and B point. We need to find out the surface integral. For that I take a limit by pick up the limits by taking off vertical shift. For vertical limits first write the y limits. Now y is varies from this line is x-axis is 0, y equals 0 to moving from this line. Now this line is y equal to x by pi. Okay. Now y varies from 0 to 2x by pi. Now x varies from 0 to this line. Now this line is x equal pi by 2, 0 to pi by 2. Now apply the limits here. Now here I common minus. Now by the y limits and x limits 0 to 2x by pi, 0 to pi by 2. Now first integrate with respect to y, 0 to 2x by pi. Now upper limit minus lower limit 2x by pi. Okay. Now this would multiply 2x by pi and sin x. 2 by pi common, maybe 2 by pi common. Now x integration x square by 2. Now x sin x. Apply the UV formula. I will write here UV formula. U integral v minus v. U dash double integral v plus u double dash. Now this formula I am going to apply here. X as it is. Integration of sin x is minus cos minus x derivative is 1 into double integration of sin is minus sin x, 0 to pi by 2. x square by 2, here plus into minus minus x cos x plus minus into minus plus sin x, 0 to pi by 2. First apply the upper limit, pi square, right? Pi square by 4 into 2 is by 8. Now cos pi by 2 0 plus sin pi by 2 1 minus lower limit x value 0 0 sin 0 0. Now remaining minus 2 by pi multiplied here, 2 1s are 2 4s are 1 pi cancel, minus we have common only here, pi remaining, denominator 4 pi by 4 minus here multiply with this here 2 by pi, now here 2 by pi only, minus 2 by pi. Okay, now this is a way to get the integration value. Thank you. I think here we can get LHS and RHS, both are same, right? Here LHS and RHS, sorry, here plus, right? Plus pi by 2 plus, now here this plus, sorry, now here also plus, we have plus, minus we have common only, not multiply each term. Now that's we can get the same term, minus of pi by 4, pi by 4 plus 2 by pi, here pi by 4 plus 2 by pi. Now LHS equal to RHS. Then we verified the Green's theorem for the given function. Okay, thank you. On next class we are going to discuss some more problem on Green's theorem. I think I wrote here. Now I will explain these problems on next class. Thank you.